So let's have a look at this function. I'm just going to write y is equal to 2 to the power of x. The derivative for this function, if we write it like y, the derivative of y is dy dx. And the derivative for this one will be, I'm going to do like this. More or less 0.7 times 2 to the power of x. 2 to the power of x. The other function we looked at was this one. Y is equal to 3 to the power of x. The base was different. Now it's 3. So dy dx of this function will be, again, I'm going to write more or less, more or less 1.1 times this function, 3 to the power of x. And this is going to be difficult to memorize all these numbers, because when we have 2 as a base it's 0.7 more or less, and when 3 is the base we have 1.1, etc. If we experiment a little bit, find that if we change the base, this number, there's a number in between 2 and 3, where this very special number here, 0.7 and 1.1, is exactly 1. That would be very handy. So if we change the base to about 2.7 to the power, then the derivative of this function, dy dx, is equal to 1 times the same function. And this makes everything much easier, because 1 times this is the same thing. So if the base is 2.7, then the derivative is the same thing, 2.7 to the power of x. So if we look a little bit closer, we'll find out that this number is exactly 2.71828, etc., and it will never stop, just like pi. It never ends, the number of decimals. But we can say more or less 2.7. So this number was so special, so they gave it its own name. So the name of this very special number is e, and you can find it on your calculator. So therefore we're going to study this very special function, this very special exponential function. Y is equal to e to the power of x, or just y is equal to ex.